Well, good afternoon, good evening, good morning, depending on where you are, everyone anyway. And welcome to another webinar from Sigma-HSE. My name is Mark Bunch, and as I look at the dashboard here, I'm just noticing we've still got a couple of people to join us. So if you don't mind, we'll just give it 30 seconds so that everybody can get in the room, and then I'll start the presentation properly. Okay, well, welcome once again. In this presentation today, I'm going to take you through some of the higher level aspects of process safety and process safety management. I'm going to start off by telling you a small anecdote. Some time ago, I was involved with providing training for the process safety leadership group, really lecturing to senior managers and CEOs and so on in process safety. And one of my clients was the operator of a large series of refineries. So this was not a small company. And we had all the most important people in the room. And there were about 17 of them. And one of the questions we asked was, who in your organization is responsible for process safety? Do you have anybody? And of course they answered, yes, we do. And before we could ask for the name, what we asked them to do was to write the name down of the person in that organization who was responsible for process safety and process safety leadership. We collected in the little pieces of paper, and we had 3 different names on there. And 2 of the names were in the room with us. So it became apparent, and it's become apparent through various incidents that have happened throughout the world over the last 10, 20 years, that there are varying levels of skill in process safety leadership, especially when it comes to senior leaders. So it's a good idea to do this kind of presentation, to remind you of the responsibilities and to give you some of the tools and the techniques and the reasons why we think it's important. So I'll start off by introducing myself. My name is Mark Bunch. I'm a principal process safety consultant, and I've been doing this job for, well, 25 years now. I started out as a chemical engineer, and I worked for a variety of EPC companies, operator companies, people like DuPont and BP, before going into consultancy after 1999, when the COMA legislation first came in, and we wrote some of the first COMA safety reports in the UK. So I've been involved in this business for many, many years now. Most of my time is spent on the hazard identification and things like HAZOPs and hazards that are so much a part of process safety management. But the training that I've done in the past and the management systems reviews and so on has been very much a feature of what I've been doing. I work for a company called Sigma-HSE. We have 3 main branches, if you like. There's the consultancy where I work. We have our testing laboratories as well, which I'll come on to in a second. And we also provide training in all aspects of process safety and process safety management. We have offices well, throughout the world now. Massachusetts is our most recent addition, but we've got offices in India and our headquarters down in Winchester in the UK. We also have testing facilities, those are in the UK, in India, and we also have the environmental laboratory in the UK as well. So I'm contractually obliged to tell you about those things. But as far as consultancy goes, this is my bit. We do process safety management and its implementation, and that's the key thing. We can advise clients on process safety and its management. We can audit as well. We can provide documentation, and we can show you which standards apply. We consult in fire and explosion hazards and electrostatics as well. My personal bit, the process hazards analysis and the functional safety, things like that. Also incident investigation as well. So we will go around companies who have had an incident and tell them why it happened. The laboratories, I was down there a couple of weeks ago, and I have to say they're very impressive. There's a lot of clever stuff that goes on down there, and I can't tell you all about it because it's too clever for me. But essentially, flammable properties we will test, but also we have the capability of doing chemical reaction hazards testing as well, which is extremely impressive stuff, I have to tell you. What I want to do today, however, is to take you through process safety from the point of view of process safety leadership. So this is a higher level of abstraction than the day-to-day business of identification of hazards, the quantification of risk, and the putting in place of safeguarding and so on, the nuts and bolts of it. This is at a higher level of abstraction. And the reason for doing it for you is that it's the lack of understanding. If people have come up through the ranks, haven't been at the coalface, as it were, maybe accountants, they're not necessarily going to be appraised of the detail, of the nomenclature, of the jargon associated with process safety management, nor might they have had the history of accidents that have happened throughout the world. It's only individuals that have memories. Corporately speaking, we tend not to have memories, so it's important that that kind of memory resides at the top of the organization. So I'm going to attack this from a variety of different avenues. I'm going to make a business case for process safety management. And by doing that, we're going to have to talk about the nature and the consequences of major accidents, because that's the backbone of that business case. Any incident involves a loss, and that loss can be devastating to the company as well as devastating to the people that it affects. I'm going to describe for you some key elements of the process safety management systems, the ones that can be affected by leadership, the assurance processes, the kind of information that should be reflected up the hierarchy to leaders so that they can judge how well their performance is against themselves and against others. Two main things that the leaders can influence are process safety culture and process safety leadership principles. Those lie squarely at the feet of the senior members, and continuous improvement as well. In the UK, at least, continuous improvement, because we are a small, crowded island, there is no such thing as zero risk. So it's virtually impossible to eliminate risk entirely. So what you have to do is to be proportional to what that risk is and continually improve as things change over time, as technology becomes cheaper, as the nature of the industry changes over time. We can at least improve year on year, and I hope to give you some of the tools to enable you to go about doing that as well. So let's make a start, and we'll start with the business case for process safety. If you think safety is important, try having an accident. This was a quote from a fellow called Trevor Klett, who is sadly no longer with us. He was an industrial chemist, but the chemical engineers kind of adopted him, and he formed the first real process safety group. quite an influential chap. But that is the business case. Try having an accident. They are far more expensive. So we know that process safety incidents can kill and injure many, many people. We've given you two examples here, Bhopal and Piper Alpha. Bhopal was the release of methyl isocyanate in India. We've said here at least 2,000 deaths. I think the figure is much closer to 5,000 deaths, the most costly industrial incident in terms of lives lost. Piper Alpha was an offshore gas platform, and there was a significant fire on there that caused the death of 167 people. We can cause intense environmental damage as well. We have two examples to show you. Cerveza in the Gulf of Mexico oil spill, the Macondo oil spill, one of BP's incidents, and huge economic disruption as well. This is an interesting aspect of process safety because these two incidents, Longford and Buncefield, were relatively low in terms of their injury and pollution scope, but they had significant effects for the economy, not only of the companies involved, but also the countries in which they operated. Longford was a gas plant explosion where they had a loss of containment that caught fire. It did kill 2 people, but it also knocked out the gas supply to the state of Victoria in Australia for some 2 weeks, and that had severe consequences for them. Buncefield was an explosion in the UK, 2010 I think it was, which caused severe damage because it closed one of the main highways, motorways in the UK, and also cut off fuel to some of the airports in the area, which cost an enormous amount of money to the UK economy. So they tend to get you in the newspapers. They can severely damage your reputation. They can have a huge financial consequence for a company. And from the point of view of leaders, you can be prosecuted as well. Both companies can be prosecuted and individuals as well. So let's explore just how bad that can be. There are revised guidelines, at least in the UK now, but a lot of other countries are of a similar mind, as it were, including China. The amount that a company can lose as the result of one of these incidents is eye-watering, really. Thames Water at £20 million. Tesco's had a diesel gasoline spillage which did environmental damage, fined £8 million, and so on. These are not insignificant numbers, and it's worth asking yourselves the question, you know, what is the largest amount of money we could be fined before we wouldn't have a company left anymore? And that's really the mindset that we need to be thinking about. There are personal consequences as well. There is a liability for senior members now as well. You can be prosecuted. The most common prosecution is under Section 37 of our Health and Safety at Work Act. I apologise that I'm going to be somewhat UK-centric for this, but you can apply your own country's legal framework and come up with something very similar, I'm sure. You can be disqualified as being a company director. There is the common law gross negligence manslaughter as well. And in 2007, we introduced something called the Corporate Manslaughter and Corporate Homicide Act. This has not been terribly successful, mainly because it's difficult to prove that an individual senior leadership person, his or her action was directly responsible. It's hard to define what is known as the controlling mind in order to achieve a prosecution. So it's much more common that a prosecution will be under Section 37, but it is part of a legal trend to hold to account people who are deemed to be responsible. So there's now been a tripling of directors and managers that have been charged under the Act. Prison sentences are not now uncommon. Fines have risen 43%, as routinely hitting £1 million, and the lawyers speculate again that this could go up in the future. So it's sobering. I mean, I don't intend to scare you, but these are the kind of figures that we're dealing with. Macondo, the oil spill Gulf of Mexico in 2010, total costs around $61 billion there. There was also an announcement after the event by President Obama at the time that BP will be banned for bidding from contracts in the US, which is significant. It hits the bottom line somewhat. Pasadena in Texas, 1.4 billion. Buncefield, average costs, total costs around $1 billion. I was told by the operator at that site that it was closer to 2 billion, in fact. So that was from the loss of reputation as well as the fines that they had to pay. If you look towards the bottom, there is 600 Welsh in Castleford. This was an explosion, and the figure here is only 4.9 million. That was nowhere near what they were fined. It was much less than that, but that relatively small amount compared to the others was enough to destroy the company. They didn't operate again because nobody wanted to do business with them. Nobody wanted to work with them, and nobody wanted to work for them. So even though relatively speaking low in terms of overall loss, it had significant consequences for the company. These are the individual factors that contribute to those costs: loss of production and lost sales, loss of opportunity revenue in those lost sales, capital costs of rebuilding, civil costs, legal costs, compensation paid to personnel, to neighbours, the public relations disaster that an incident can provoke, and the cost of subsequent investigation and reviews. We'll say more about this as we come into looking at BP, but just to give you some idea of what that did to BP's share price. You can see here, I don't know if you can see my cursor moving around, I hope so. I could see it when I was looking at the screen earlier, but around 2010 you see a significant drop in share price. They were ripe for takeover at that point. It recovered, but not anywhere near what it was. So these can have, long-lasting impacts as well. So we talked about loss of life, we talked about the environment, and we talked about loss of reputation. There's also changes that are introduced as a result of these incidents that don't affect you, but do affect others, in that they affect the legislation. So giving you 4 examples here. Flixborough in 1974 was a significant incident in the UK. And it was a fire, it was the ignition of cyclohexane, I think it was, but it killed 50-odd people. The UK had some process safety legislation in the pipeline, but there was a general election going on at the same time, and that was put on hold. After Flixborough, it came back into the fore. And provoked really what was the first set of process safety legislation, as well as our main Health and Safety at Work Act, which was also issued in 1974. Seveso in 1976, this is the namesake of the Seveso Directive, which was the EU's implementation of the UK's process safety legislation as well. Bhopal in 1984, I mentioned, and Bâle in 1986, both of these were environmental. Well, sorry, the Bhopal was loss of life. Bâle was an environmental release. Seveso too, not many deaths as a result of Seveso. In fact, I don't think there were very many, but it was a significant environmental loss, with lots of farm animals being slaughtered and lots of agricultural land being left unusable as a result. So I've included, I don't intend to go through this terribly much, but this just gives you the timeline of those effects of major incidents on the legislation. So you see SEMA introduced here, which later transposed into COMA in the UK, and the Seveso Directive and others. Those get regularly updated and have been reasonably effective. But even having said that, we still tend to have these accidents. So we have Bunsfield here, you can see the tank there on fire, Chevron Pembroke in 2011 explosion, yeah, so Ludwigshafen, the Condo oil spill, of course, and a slightly smaller one, but nonetheless devastating, the Bosley Mill, which is wood processing facility, which had a dust explosion and led to the deaths of people as well. So why do they happen? There are features that recur time and again. Normally, we see multiple failures, and that means that there are failures at different levels throughout the organization. Failures of plant, failures of the processing, and failures in people's performance as well. At a number of levels within the organization and across a number of functional groups as well. So you will find very often that frontline staff may well have made mistakes, but often and tellingly, over the longer term, senior executives have made errors as well, either through business decisions that they've made, or lack of resources, or letting go the wrong people, or lack of training and so on. Many of those things we'll come across as we get further into this. So process safety and leadership. After the Texas City incident, there was a review panel set up, and this was the Baker panel, which looked into why the accident had happened. And it found various failures at different levels in the organization, exactly as that previous slide described to you: operator error, failures of plant, and so on. But from our point of view right now, it was the organizational features that they found lacking. So there was no safety ownership at board level. There was nobody with overall responsibility. That had been devolved down to lower levels within the hierarchy. There was a poor management response to deep-seated safety problems. That means to say that even though the problems were recognized and reported higher up the hierarchy, they weren't given the gravitas and the seriousness that they actually deserved. There was a focus on the wrong safety metric. So at Texas City, the lost time injury rate was actually pretty good, but it gave a false sense of security. They'd done well in eliminating slips, trips, and falls and occupational safety kinds of incidents, but they had failed entirely to recognize that they had a serious process safety deficit when it came to looking out for the major accidents. A mechanical integrity program was needed. There was a checkbox mentality. This is part of the culture of the system. No reporting, no learning culture that went with it. So even though losses of containment were not uncommon, it never fed into the culture that had a potential to do something about it. And poor management of change as well. So these were the failings, and the Baker panel picked up on this. They said clear, positive safety leadership is vital. It requires board level involvement, critically competence as well, so that people understand what the issues are and understand the information that they're being given so that they can make the correct decisions about it. And board level visibility as well, the promotion of a safety culture needs to be at the top and needs to find its way down the hierarchy. So what do leaders do? They set the roadmap for doing this. They have an opportunity to influence performance beyond what they might initially think. It's generally less granular, which means that they've got a higher level of abstraction, I refer to this again, than the people who are actually responsible for achieving those targets. And we'll say something about how this is achieved later on, how visions can go down through policy deployment and actually make it through to making a difference. But I want to come back to one thing I mentioned earlier, and that was BP's safety culture at the time and their reliance on the wrong measures for their safety performance. And that's to say there is a difference between occupational safety and process safety. Process safety is more specific. It deals with the major accidents that have the potential to get you in the news. These are typically fires, explosions, toxic releases, with the potential to harm a large number of people. It's all part of a continuum. It's all part of the whole gamut as to managing health and safety correctly. But we use a graph that looks like this. Again, I hope you can see my mouse, but we start off at the bottom left corner with the x-axis being the likelihood. So we go from higher probabilities down to lower probabilities, and then increasing severity going up here. So it's a continuum. So occupational safety tends to deal with the more likely, lower harm type of events, and process safety tends to be the much less likely but much more consequential style of risk. Now, everything was focused from BP's point of view at this end of the scale, and those are the metrics they used, and those were the bases on which the company measured its performance. So it can be to the detriment of process safety, the things that are actually going to kill many numbers of people. Some of the tools are the same: permitry, risk assessment, policies and procedures. Those are exactly the same in occupational safety as they are for process safety, but process safety is more rigorous. It requires more thought, more rigor in order to implement things like quantified risk assessment, layers of protection analysis, detailed hazard studies, HAZOP studies. It's those kind of things that are in addition to managing occupational safety effectively. So I'll finish with a major accident definition for you. Any occurrence, it's the serious nature of it, a serious danger to human health, a serious danger to the environment, involving dangerous substances, distress to everyone, substantial number of medical treatment cases, people seriously injured, prolonged treatment, that kind of thing, and the death of individuals as well. Those are the kind of things that we're talking about when it comes to process safety. It's the major things that might get you in the newspapers. So we need to manage these things, and we do that through process safety management. So I'm going to spend a little bit of time on this because it's going to influence how senior leaders see this kind of data and are in a position to react to it. There is good guidance. There usually is. There's a variety of guidance, but in this case, I think there was a lot of copying and pasting, because the framework itself is not difficult. It's comprehensive, and it's not terribly onerous to implement either. The one we usually use as an example is this one, the Center for Chemical Process Safety, a US documentation, and in it has 4 what they call pillars. In the UK we call them focus areas, but they do exactly the same thing regardless of which country you're in. A commitment to process safety, first of all, a detailed understanding of the hazards and the risks that you are able to impose on the public and impose on your workers. The systems for managing that risks, and systems for improving continuously as well. So these are the 4 pillars. Now, typically, we would expect that senior leaders are mostly involved with number 1 and number 4. The commitment to process safety, putting in place the measures that will allow people to recognize and manage the risks, these bits, which are more carried out by engineers, senior managers, operators, and so on. And number 4 as well, the systems for continuous improvement. That is recognizing how your company performance is going when compared with the standards and the processes and the policies that you put in place up at the top. So setting everything in stone at the top, seeing if everything is being achieved at the bottom. Those are the main areas where senior leaders see their roles. With hazard and risk, the measures must include the consideration of both the outcome and the likelihood of that event occurring. That means that it's not simply looking at the hazard, it's looking at the consequence, it's looking at the probability or the likelihood that something happens as well. That is the risk measure. It is incumbent upon you to do that probability evaluation as well. And that means a little bit of judgment is made. When it comes to risk, there are 4 useful questions, and they all are what. It's the risk of what, from what, to what, and then the final question is so what. And that's the senior leadership question. It might be the risk of somebody dying in a fire, from the inadvertent ignition of a flammable cloud. Risk to what? To members of the public. It might be to the operators. And the question is, so what? Is it bad enough that we need to do something serious about it? What are the safeguards and measures that we need to have in place? So these sources of risk is useful to think in terms of 3 Ps: the plant, the people, and procedures, and the processing itself, or the processes that you use to control the process. And you can think of these failures in plant, failures in the people, failures in the processing as giving rise to the risk. So in order to calculate your risk, you need an idea of severity, and there are various tools that will give you that information. Typically, we will do some modeling. If you don't know how to do that, you can give me a call and we'll do it for you. But that allows you, based on the severity that you're calculating, to come up with a number of people or an area of the environment that you've got a chance of hurting. So we do that through software modeling and inference as to how many people, likely numbers of fatalities and injury. And that should then prompt the question, what further action should we take to prevent this incident from occurring? The question is, how do you decide what is good enough? And that's where risk matrices and tolerability of risk calculations could come in useful, because they will give you those answers. We would typically suggest something like a hazard or a hazard identification study as a basis, and we'll score it. We'll measure depending on the consequence and depending on the likely frequency that goes with it, which allows you to place yourself on a risk matrix to say, okay, we need to do something more, and this is how much we really ought to spend in order to achieve the risk reduction that we're looking for. And a risk matrix, I'm sure you've seen these in the past, but they generally look like something like this. It's not a million miles away from the earlier graph that I showed you. You've got increasing likelihood this time along the top, and increases severity going down. So anything with high severity and high likelihood is going to put you in the red box. So at that point, you might decide to do something significant about the way you're operating. If you're a nicely low severity and low likelihood, you are required to do less to control the risk. And the tricky bit is always in the middle. And this is the point at which you really ought to ask, what more can we do, and why haven't we done it? And the what more can we do question is usually a workshop with a lot of people who are clever sitting down and saying, well, we could do this, we could spend a bit of money here, we could change this process and so on. And the reason why we haven't done it is because it's too expensive. It's a cost benefit analysis. If the cost of the measure is grossly disproportionate to the value that it brings in terms of risk reduction, then it's less likely that you're going to be able to justify that expense as a result. But you should make those decisions. You should look into what else can we do and how much is it going to cost us. So we need to document this. There is a legal requirement to document this decision making. So all this hazard identification that we do, all the risk analysis that we do, the risk assessment, the so what, the asking of those 2 questions, what more can we do and why haven't we done it, that is all part and parcel of the documentation that goes into describing how well you are maintaining your low level of risk when operating. In the UK at least, and this is a useful thing for anybody to use, we have something called the tolerability of risk criteria, and we use this quite frequently. It's got exactly the same axes increasing risk going up here. This time it's done in terms of risk rather than consequence. And there are two benchmarks set, these two lines here, one very, very low and one quite a bit higher. And if you find your risk when placed on a risk matrix resides in this top region, what is termed here unacceptable, we have a legal requirement to stop work at that point and to put in place risk reduction measures that reduce that risk, first of all, to something that is in the middle here tolerable, as long as you've asked the questions, what more can we do and why haven't we done it? The so-called, is your risk as low as reasonably practicable, or a LARP? And then ultimately, if we can get the risk down here to broadly acceptable, you are required to do much less. But if there are, say, a couple of low cost, easy measures that you could put in place, there's no reason why you shouldn't do them. In particular, if you do have an incident, it would be very hard to justify in court the reasons for not having done them if they were quick and easy. Generally speaking, I think this works quite well. The only difficulty I have is when doing the risk analysis, what you need to remember is that this particular level for a single fatality is set at a frequency of 10 to the minus 3, or a 1 in 1,000 chance per employee of dying per year. And this one at the bottom is set at 10 to the minus 6, or a 1 in 1,000,000 chance of dying per year. So the difference between these two levels is a difference of 10 to the minus 3. And if your risk matrix is calibrated in terms of orders of magnitude, that's 3 orders of magnitude. Now, if you're running a hazard identification or a risk analysis program, and you've got a team of people sitting around a table, it's surprisingly easy to argue yourselves one way or the other that takes you from being either unacceptable down to tolerable, just 3 orders of magnitude, just in a conversation between friends. Somebody might think it's a major injury, somebody else might think it's fatality, somebody thinks 10 to the minus 3, somebody thinks 10 to the minus 4, and before you know it, you've moved those 3 orders of magnitude from one to the other. So this is a very useful tool for ranking risk, for telling you which of the scenarios, which of the incidents that are going to hurt you the most, but it's less good in terms of absolute risk, for which other tools, shall we say, are more effective. This is very good for ranking, not so good for absolute risk. So those are the kind of things that we would expect senior leaders to be, first of all, aware of, and secondly, to at least understand. Even if they don't get involved with the nuts and bolts of producing the information that goes into this analysis, they need to be able to understand the outcome, because they need to be able to resource the remedial work, or the additional safeguards that might have to go into place in order to meet the criterion. So it's useful for process safety leaders, necessary even for them to understand diagrams like this and the kind of work that sits behind it. Excuse me, I'm losing my voice now. So there is some guidance. I mentioned the CCPS. You can also find on free download successful H&S management, so-called HSG 65 guidance. CCPS, I mentioned. The Energy Institute is the UK implementation of the CCPS guidance. It's very, very similar. It has these 4 focus areas rather than the 4 pillars that CCPS had. There is an organisation called the PSLG, the Process Safety Leadership Group, which was formed in the aftermath of the Buncefield explosion in the UK. There is guidance on particular aspects. OSHA has guidance on process safety management of highly hazardous chemicals. The COMA regulations has guidance as well, latest guidance based on the 2015 update, and specific guidance on things like performance indicators, the HSG 254. So the HSE's guidance is all on free download, including for COMA as well. CPS, you can buy the book. we have it, but it's very good guidance actually. I quite like using it. So I'm going to stick to it as far as possible, because it does the job of all the others as well. And I mentioned earlier, it has these 4 pillars: the commitment to process safety, hazards and risks, understanding hazards and risks, management, and systems for continuous improvement. It implements those through process safety framework. So within each of those pillars, there is a breakdown. The Centre for Chemical Process Safety has 20. The Energy Institute has 18. Missed a couple there, but it covers everything from safety culture right through to auditing at the bottom and everything in between. So you can see here, process safety culture is the process safety leadership function. Standards, codes, regulations in laws, the identification sits up at the top, competency sits up at the top, workforce involvement is getting down now. So getting operators, engineers, senior managers involved, as well as senior leaders. And as we go through this, you'll see a variety of roles that are captured. Process safety, in terms of the safeguarding, senior leaders need to be aware that there is a hierarchy of approach to managing process safety risk, and it starts, we call this the onion diagram, but it starts with the design of the process itself. We define from that a safe operating envelope, but we always expect that there may be excursions from that self-operating envelope, and those excursions are controlled by what we call a basic process control system. That might not be a computer, might be a person with a piece of paper labeled procedure, but it's whatever you have that maintains the process parameters, the things that can get out of hand and end up in a loss of containment and hence a major accident. It's whatever you have that maintains that happy status. If you have an excursion from that, we have some alarms that may give us indication. I've termed these critical alarms. These are the ones that you actually need to do something about, rather than just silence. They're not there for being a nuisance. These are the ones where something has gone wrong that the operator needs to do. So with critical alarms, there is a criterion that you can think of, and that is that the operator needs to first of all be aware. He needs time available to him to actually do something about it. He needs a written procedure to be able to follow what to do about it, and he needs to be audited to make sure that he does do something about it. So that's part of a demonstration that an alarm is actually worth something to you. Rather than just a noise in a room, it's actually going to achieve something and get the process back under control again. Because it can fail, because it has what we call a probability of failure on demand, there is always a chance that it won't do what it wants. We have another layer of protection, which might include these things called safety instrumented systems, which are automated functions that perform a safety function and don't require the use of a human in order to achieve that. They are typically more robust than other layers of protection in that they have a defined probability of failure on demand, a defined reliability that is proportional to the risk against which they are offering protection. But they do have a probability of failure on demand, which means they can fail, particularly if you don't look after them. So we have further devices around that, maybe physical protection devices like pressure relief valves, bursting discs, things that just are and are there to perform a safety function. After that, we've got a loss of containment going on. We might have further devices like isolation of the supply, bunding to capture anything that is lost, and then gas detection, deluge systems, activation of the on-site emergency plan, and finally activation of the off-site emergency plan. So you can see there are many layers to this, and there is a you can see a hierarchy as we go out, preventing the incident from happening in the first place, controlling the rate of release once you've got an issue going on, mitigating the release finally. So prevention, control, and mitigation. But ideally, if we can design out the hazard in the first place, that's our best course of action. And again, I need senior leaders to be aware that this diagram exists and that these are the ways by which we manage risk in the first place. Essentially, that encapsulates everything that we need to do. A safe design, a way of controlling, a way of recognizing and then doing something about it when we go wrong, and something to mitigate the consequences if all else fails. So the PSM Focus must identify these safety critical elements. Anything that does any of those jobs becomes special, and you must look after it as being special. Test it, audit it, design it correctly, install it correctly, and all the other things to make it seem special. You have to tell people why they're special, including the senior managers who are paying for it and the operators who are going to use it, why that job must be done right every time. And you can think in terms of these P's, these plant, the process, the people, and the procedures that go with it. You can have a safety critical piece of plant, you can have a safety critical process, you can have safety critical people as well, and safety critical procedures. All of them need to be treated as being special in process safety land. That is to say that they must be inspected, they must be tested periodically, and they must be maintained. And the reason that you do that is so that you can get your process safety performance indicators and see if you're more or less likely to have an incident as a result, and that is part of your audit and review process. These safety performance indicators, which I'm going to cover very shortly, are the way by which you measure performance, and it's these figures that the senior leaders need to be aware of. So the leadership requirements. I'm going to deal with this last number 4 pillar, the systems for continuous improvement. I'm going to start with the first one first, though. Commitment to process safety. So I beg your pardon. Yes, it's the first one I'm going to deal with. Makes more sense, doesn't it? Commitment to process safety. What does that include? From the elements within that in the CCPS guidance, we have 1, 2, 3, 4, 5 particular ones that apply to senior leaders. The process safety culture, the setting of the culture, compliance with standards, regulations, etc. Competence, training and performance, the hiring process, if you like, workforce involvement, and what is termed here stakeholder outreach. The difficult one here is culture, because if I came to your site as a consultant, there are 0 actions I can give you to improve your safety culture. Safety culture is a product of other things. It's first of all a product of people's attitudes. And if we're talking process safety, their attitude to process safety. Attitudes themselves are a function of people's behaviours, because I can't give you any actions either on how to change attitudes, but I can give you actions on how to change behaviours, and those typically stem from mentoring, coaching, having the right procedures, training, and the messages that come down in terms of policy deployment. That is how you change behaviours, in ultimately how you instill, and it's a long-term commitment to do so, but it's effective when it works, an effective process safety culture. The other one I'll mention is workforce involvement, because that's tied in so much with culture as well. Getting people involved in process safety through things like forums, process safety. What was I've forgotten the word now, but not auditing, but attitude survey, for example, looking for incident and near-miss reporting that doesn't simply rely on the occupational safety side of things as well. Those are all very good ways of getting the workforce involved. A consistent message is important. Understanding hazard and risk is the second on the list, the second pillar, and that covers things like the process knowledge management and the hazard and the risk assessment. So it's all the chemistry, all the stuff that we can test for you about your processes and the way by which you go about determining what the overall hazard and risk is. The third pillar is the management of that risk, maintaining the process within those envelopes. So you can think back to my onion diagram, maintaining the equipment and the testing of protective devices. And again, you can think back to my onion, the compliance with procedures, and having a management of change system that works for you. There's a reason why they're difficult and why nobody likes them. It's because they do a very good job of recognizing when things change that may affect process safety, when they're implemented correctly. The last one was the learning from risk bit, and this is the continuous improvement section. So senior leaders need to be able to understand what happens when an incident occurs through things like incident investigation. They need to understand the information that is presented to them when measuring process safety performance through process safety performance indicators. They need to adequately resource the audit. They need to be able to accept the results of an audit when it doesn't tell them what they want to hear necessarily. This was the case at BP. Audits were conducted and those messages were being sent back to BP, but perhaps cleansed a little of some of the bad news that sat behind it. They need to review the results of those performance indicators and audits effectively, and to be able to make the right decisions as a result of those. And then there's the comparison, not only with what they were doing this time last year, but how they compare to other people who are working in similar sectors or across sectors. Internal, external benchmarking is what we call this. It's comparison with your process safety performance with the process safety performance of others who are operating to similar high hazards and high standards. But with all these things, it's the business decisions you make that have the biggest effect. So you need to understand the major accident has a potential of a business decision. If that decision is to reduce maintenance costs, for example, this happened at BP. Reduction in workforce, this happened at BP as well, because critical people who understood the process were no longer available to them. It ensures, or the businesses should ensure that the PSM is systematic. It's only through it being systematic that you can ensure that everything necessary is captured. It must identify where you are vulnerable and be skeptical of any good news that comes back your way. It must focus on the major accident safety outcomes, the fires, the explosions, the toxic releases, and it must work together across industries so that good knowledge is accessible to all. There's a really good phrase about a wise man learning from his mistakes and a wiser man learning from the mistakes of others. So sharing this good practice is a very good thing to do. We are not competitive with one another when it comes to process safety performance. I think that's probably a good way of putting it. As another illustration of why these business decisions are key, I'll come back to the Longford explosion. This was the gas plant in Victoria. So I mentioned earlier that the state of Victoria was without gas for 2 weeks. That included all the schools, the hospitals, the households. It introduced the necessity for new regulations, the fines and the compensation that had to be paid, as well as the people who lost their lives. But it was business decisions primarily that had contributed to this disaster. There was no engineering support at the plant. The engineers had been pulled back to head office in Melbourne as the result of a cost-cutting measure. The senior leaders again recognized that their safety performance was good because they were measuring the wrong things. They were measuring occupational safety performance and they'd had no slips, trips and falls for a while. It was close to zero, their lost time injury rate. So they were measuring and receiving information about the wrong things. In fact, before this incident occurred, they'd had a similar incident with a loss containment of exactly the same stuff. It was gas condensate, and it had gone into their incident reporting system, but it was treated as a slip hazard rather than the loss of containment of a flammable liquid that could lead to a fire or an explosion. Therefore, when it reached senior leaders, it didn't get the importance which it really should have done. Consequently, 2 weeks later, they had the same release. This time it caught fire, and this time it killed 2 people. So it's a critical feature, isn't it, that these business decisions that are made have safety outcomes. And if you don't, at the top of the tree, understand this and understand the import of those business decisions on your process safety performance, this is the kind of thing that can and ultimately will happen. So how do you get high-level policy down? There is guidance for this. Health and safety management. I believe this is still in publication. It's a document that I've actually found quite useful, but it uses an old model, so I'm going to update it for you today. So this is the assurance process for risk management. I don't need that slide. I've been through that, and I want to get through to, here we are, the performance indicators. Because this is really the kind of measure that the senior leaders have time for, because it's a snapshot. It's a good, quick and easy way for them to understand exactly where they are and what direction things are moving. So, do the systems that you've got in place operate as intended? Are your major hazard risks being effectively managed? And what is the trend? Are we getting more likely to have an incident or less likely to have them? They have other benefits as well. If you spot that you've got an increase in the number of, I don't know, small losses of containment, and you do something about it, your ultimate production goes up, or your productivity goes up. You gain efficiency as a result of that. Scottish Power in the UK published a paper about how they'd improved reliability by a considerable margin and reduced their fixed maintenance costs by improvements in reliability as the result of looking at their process safety performance indicators, which is very good, because it's a win-win, isn't it? You can invest that money any way you like, but it's nice to have that kind of payback from something that is also doing some good. It reduces the events themselves, and it improves overall productivity. So choosing the right measure, and when that measure is useful to you, keeping it in, but if it's leveling off, ditch it and go measure something else where you might get some change. It's more about the change in the way that you're performing rather than the absolute performance level, I should say. A mixture as well. We have 2 types of performance indicators: reactive and active monitoring. So it's lagging indicators and leading indicators. So leading indicators give you an indication of whether you're likely to have an incident or an accident, and lagging ones allow you to promote learning from mistakes following. So a lagging indicator would be a loss of containment. A leading indicator would be something like the number of maintenance activities carried out on a particular safety instrument device within the time frame, i.e. nothing's gone wrong, but these are the kind of things that we're doing in order to make sure they don't go wrong in the future. So a mixture of both leading and lagging indicators is the way to go. Finally, I will say a little bit more on culture and the process safety leadership group commentary on culture. There is a definition which our health and safety executive has, which is quite long. Product of individual and group values, yes. Attitudes, competencies, etc., yes. Behaviour. So all the things I mentioned earlier. But it's how the organisation behaves when no one is watching. That's a really good definition, I think, of culture. 2 o'clock in the morning, night shift, you go out on plant, is everybody wearing the correct PPE? Is a good indicator of how well you are managing culture. Culture makes it easier for you to deploy different policies, and let's look at how you might go about disseminating a process safety policy. The principles are that you should have clear and positive leadership, competence, engagement, board level visibility and promotion, workforce engagement, the PSPIs, and sharing of best practice. Those are all the things I mentioned previously about what good process safety leadership would look like. So how well do you do at that? I'm going to skip that slide and go straight to this one. If you have a process safety policy, well, let's say you don't. Let's say you want to manage process safety well. Policy is the first thing you do. Have it in place. Make sure that the relevant people know about it. Who is responsible for achieving it? The workforce's knowledge of their own ability to play a part in it. And then it's a question of, well, is it working? How do you know if you're achieving it? What do you do about it if you're not achieving it? And how good is it? And do you need to do anything else as a result? So that is typically concerned continuous improvement. It's policy deployment. So for policy deployment, sorry, I'm on the wrong sheet of paper here. The key principles are that you should focus the entire organization on these few vital objectives, whatever those are within the policy. They should drive responsibility to the appropriate level in the organization so that people can affect the things they can affect, that they're empowered to affect. If you're going to have any chance of doing an effective measurement and review, then there needs to be regular dialogue, there needs to be feedback, so that all employees recognize and understand their contribution. And the way we typically do that is through a model. And I'm going to skip to the last slide to show you that model, because the others are just words. It's this one. Plan, do, check, and act. It's the best way. You plan to do something, you do it, you check that it's working, you form an action plan based on the outcome of that check. And you can do it for every one, the 20 elements that appear in that Centre for Chemical Process Safety document. The process safety culture, the compliance, the performance and training, the workforce involvement, knowledge management, risk assessments, and so on, contractor management, management of change. These are the things for which you can produce a plan, carry out that plan at the right level in the organization, check that it's working, and act in order to update that plan based on the outcome of the check. If you do that, and you do that with the understanding of what process safety is and how leaders can affect it through their business decisions, then you've got a much better chance of preventing the next major incident as a result. And with that, I apologize, I've gone 4 minutes over, so I do apologize for that. But thank you very much for being with me. It's a difficult one to do this because there's so much that I need to cover. And with that in mind, if there's anything else that we can do for you, just drop us a line. If there's any questions at all, we'd be happy to answer them. But I appreciate that this has been somewhat of a rapid trawl through, but there is just so much to cover. And once again, thanks very much for your time. We hope to see you soon and for the next webinar. But in the meantime, have a jolly good evening and yes, well, good weekend as well. So thanks again and bye-bye.